Composition of functions. This is how we're going to combine functions where the output of one function becomes the input for the next function. So we are going to be plugging f of x into g of x. That is a composition. Here we're plugging g of x into f of x. This is the notation. You'll see it both ways. This says g composed of f of x. This says g of f of x. That's how it is read. Okay, so let's do an example. I'm going to do a composition. This says g of f of x. So I'm going to plug f of x into g. So I'm going to write g. This is g right here. I'm going to put parentheses where the x is. And I'm going to plug f of x into g. So this is f of x right here. I'm going to plug that into g. So this is my function, 2x squared minus 8. Now I'm going to plug g into f. So I'm going to write f. This is f, x squared. And I'm going to put g inside of it, 2x minus 8. Now this time I'm going to put f of 4 into g. So f of 4, this is f, I'm going to plug 4 into it. F of 4 is 16. Now I'm going to plug this output into g. So g is 2x minus 8. And I'm going to plug in that 16. 2 times 16 is 32, minus 8 is 24. So g of f of 4 is 24. Let's talk about the domain of these compositions. Let's go back to this example. Here, f of x equals x squared. That graph looks like this. So my original domain is all real numbers. Here for g of f, or g of x, this is just a linear line. And the domain here is negative infinity to infinity. So since my domain for both of the original functions are all real numbers, this domain is also all real numbers. And so is this one. It's all real numbers. But that won't always be the case. Let's look at this one. I'm going to plug f of x into g. So this is g. And I'm going to plug f of x inside of it. Now, let's talk about the original domain here. Normally, it looks like this. So your domain is from 0 to infinity because there's an asymptote right here. The domain for this linear line is all real numbers. So the domain that I am plugging in goes from 0 to infinity. So that is my domain for this entire composition. Let's go the other way. Let's do let's do f of g of x. Let's do that. So I'm going to plug g inside of f. Now, what I am plugging in is not restricted. However, since I'm plugging it into ln, it will become restricted, okay? So I'm going to do a little bit of algebra here. I'm going to pull out a 2. This is the same thing. 2 times x is 2x. 2 times 3 halves is negative 3. However, now that it's in this format, I can tell that it went to the right 3 halves. So now this equation looks like this. There's an asymptote at 3 halves. So that means my new domain is 3 halves to infinity. Let's try this one. I'm going to put f of x inside of g. So I'm going to write g, and I'm going to put f of x inside of it. Okay, so this domain is restricted. This went to the right 6 spaces, and it looks like this. So this domain is 6 to infinity. This domain is all real numbers. So what I'm plugging in is not restricted. But once I plug it in, it becomes x squared minus 9. This one is restricted. The domain here is negative infinity to negative 3, and then 3 to infinity. Let's look at this one. We're going to plug g of x into f. So this is f, and I'm going to plug g inside of it. Now notice, what I am plugging in has a restricted domain. We can't just plug in anything, okay? You can only plug in numbers from 6 to infinity. So that is your domain here. So let's talk about the difference between these two problems. Here, what I plugged in, it's not restricted. The original domain here is all real numbers. You can plug in anything into this one. However, since you put it under a square root symbol, now your domain is restricted to this because we plugged in this function into a square root symbol. Here, we started out with the square root symbol. You can't plug in just anything here. You can only plug in numbers 6 and bigger. So that's your domain for this one. Okay, now we're going to plug in f of x into g. So I have, this is g, and I'm going to plug in f of x inside of here. Now, this domain just looks like this. It's all real numbers. Okay, so let's think about this. If I can plug in anything in here, let's say I plug in like a negative 5. That means I'll have natural log of e to the negative 2. This is just natural log of 1 over e to the power of 2. Well, this is a positive number. So that works. No matter what number you plug in, say you plug in negative 150. This will become negative 143. Negative 143. That's still positive. Okay, so no matter what number you plug in, whether it's negative or positive, this will always remain positive. So your domain here is all real numbers. What you plugged in is not restricted. And you can test numbers to see that this inside part will always be positive. And you can always take the natural log of a positive number. Okay, let's look at this one. We're going to plug f of x into g. So this is g, and I'm plugging in a natural log. So this one is all real numbers. But what I am plugging in is restricted. This goes to the left 5. So there is an asymptote at negative 5. Your domain here is negative 5 to infinity. So what you're plugging in is restricted. So our domain here is negative 5 to infinity. Let's try it the other way. We're going to plug g of x into f. So we have the natural log of x plus 5. Oh, but instead of an x, I'm plugging in 4x minus 1. So this becomes the natural log of 4x plus 4. And again, guys, we need to rewrite this so that it's in the proper format. We're factoring out a 4. So now that I rewrote it by factoring, I know that this goes to the left 1. So your domain, if you graph this, it went to the left 1. So you have an asymptote at negative 1. So your domain here is negative 1 to infinity. Okay, last example. We have f of x going into g. So I'm going to write g nice and big. However, instead of an x, we are plugging in f. And f is 4x squared plus 44x plus 96. Now remember, whenever you have any type of fraction, you cannot have 0 in the denominator. Okay, so let's figure out what numbers would give you 0 in this denominator. First, guys, let's do a little bit of algebra. I'm going to divide all of these by 4. So 4 is on the outside, and this will become x squared. 44 divided by 4 is 11. 96 divided by 4 is 24. So I can factor this. Two numbers that multiply to 24 but add to 11 are 8 and 3. So this can be written as 4x plus 8 times x plus 3. So this problem is 4x plus 8, x plus 3. So that's how we're rewriting this problem. So I know that x cannot be negative 8. Because if I plug in a negative 8 here, this whole thing becomes 0. And we cannot have 0 in the denominator. So x cannot be negative 8. Also, x cannot be negative 3. Because if you plug in a negative 3 here, negative 3 plus 3 is 0. And 0 times all of this will be 0. You cannot have 0 in the denominator. So that is my domain. X cannot be negative 8 and it cannot be negative 3. So let me draw you a picture of what this looks like. Here's negative 8 and negative 3 on a number line. You can't be negative 8 or negative 3, but you can be anything else. You can be from negative infinity up to negative 8. You can be in between negative 8 and negative 3, and you can be anything bigger than negative 3. So this is how you would write your domain in interval form. You can be everything except for negative 8 and negative 3. Yeah, I can do another example of that. So f of x, let's make it e to the x minus 1, and I'll make g of x natural log of x. So we're going to do f of d of x. So I'm going to put g inside of f. Oh, I'm sorry. We did f first. Okay, we're going to put f inside of g. So I'm going to write g nice and big, and I'm going to put e inside. E to the x minus 1. Remember, this domain is all real numbers. You can plug in any number. So let's just say I plug in negative 100. This becomes natural log of e to the negative 101. This is the same thing as the natural log of 1 over e to the 101. This is positive, guys. You can take the natural log of a positive number, okay? So you can plug anything into here. So your domain is still all real numbers, okay?